All right, so we're going to start with long division. We're just going to practice some of these. We'll do some synthetic division. I've got a couple of theorems for you, and that's all your notes are, really. So first few here, we will divide with long division. And I'll walk you through the first one in case you don't remember long division. So we have x cubed plus 3x squared plus 3x plus 2, and that is all divided by x plus 2. Okay, so first the setup. Whatever you're dividing by, your divisor goes out front. So x plus 2 is going to go out front. And the x cubed plus 3x squared plus 3x plus 2 goes under there. Keeping yourself neat and organized while you're doing your work on long division is very helpful, so you don't screw up a sign or make little mistakes like that. So the way we start with long division, I'm looking at this first term, x cubed, and there's two ways you can think about it. You can think I'm dividing it by the x that's over here, or what could I take x times to end up with this x cubed? So what do you think, guys? What do we need? X squared, yeah. So x squared goes up here. It doesn't have to line up perfectly above anything. It's just your first term, your result here. Okay, then I take that x squared and I multiply it by what's out in front. So I multiply it by the x plus 2. So x squared times x is x cubed. X squared times 2 would be plus 2x squared. Those you do want to line up nicely. The cubes line up, the squareds line up as you go along. Okay, with long division then, do you guys remember what we do with these? Subtract, yeah. I put it in parentheses and then put my subtraction sign out in front so I don't screw up a sign. So x cubed minus x cubed, that's gone. That should happen every time. If these two don't cancel out for you, you made a mistake and you should go back and try again, okay? Those two should be gone. Then it's 3x squared minus 2x squared. So I have just x squared left. And then I get to bring down my plus 3x. And then you start the process over again. So I look, what do I take x times to get x squared? X. So I'm going to write plus x up here. And then I multiply, so x times x plus 2, that's going to give me x squared plus 2x. Put it in parentheses, subtract. The x squareds are gone. 3x minus 2x is just x. Bring down my plus 2. What do I take x times to get x? 1. So I'm going to write plus 1 up here. You repeat the process again. So 1 times the x plus 2 is x plus 2. Bless you. Parentheses, subtract. You get nothing, right? 2 minus 2, we're good. What does that mean, that I got 0 at the end?
Well, it's a remainder of 0. Does it mean that x plus 2 is a factor of the x cubed?
Yes, very good. Yeah, both of those things. Remainder 0, and if your remainder is 0, whatever you were dividing by is a factor of your original polynomial. Good. You remember stuff. That's exciting. All right, so your answer here is this x squared plus x plus 1. Okay. That was a pretty simple one to start with. We didn't really have a lot of negatives going on, no remainder. So let's try another one. I'm going to have you guys try this one. Let's do, and I'll move it up in just a second, 3x cubed minus 2x squared plus x plus 5 divided by x minus 2. Okay. So try that one with long division. I know we could do it with synthetic, but try it with long, okay? And I'm just walking around and looking at your remainder. If you got your remainder right, it's very likely that Yeah, then that makes sense. All right, guys, let's go through it. Bless you. Most of you got there. It's so easy to mess up a sign in this, guys, so don't feel bad if you got something wrong with your subtracting. Sorry. Bless you. Okay, so I need a 3x squared as my first term. That'll give me 3x cubed minus 6x squared. And then, guys, I always put it in parentheses with that minus out front. It just helps remind me to subtract everything. -2 minus -6, that's going to be positive 4x squared. And the thing that stinks with, you know, long division, if you miss one sign, everything after that will be wrong. You know, it messes up everything the whole way through. Guys, can we get masks up over our nose? Thank you. All right, so then I start again. I need a positive 4x. So 4x squared minus 8x. I'm going to subtract all of that. That's really adding 8x, so I'm at 9x, and then plus 5. So I keep plus 9. 9x minus 18. Again, subtracting all of that, I get 23. Now, the way you write the remainder, I saw a few people just write R23. It's not the proper way to write the remainder. Yes, the remainder is 23, but the way you write it, get in the habit of just putting a plus sign and then making a fraction out of your remainder. So I'm just going to write plus and then 23 over what I'm dividing by. So over the x minus 2. And that is your answer. Now, the reason I say always put a plus before it, let's say your remainder was something like -x plus 3. And you wrote minus x plus 3 in your remainder, you've screwed up the signs on your remainder. So if you just do plus and then make your remainder out of it, you won't have any sign issues at the end, okay? Questions on that one? Okay, let's try again. Leon. All right. Let's try a little trickier one. Let's do x squared plus 4x plus 3. I'm sorry, guys. That's what you're dividing by. Hold on. Write it the other way. 3x squared, sorry, minus x cubed minus 3 divided by x squared plus 4x plus 3. What do you need to be aware of on this one? Yeah, that first polynomial is not in order, right? It's not in your standard form. So make sure when you do the division, you reorder that and careful with your signs when you do that. So again, I'll give you a second to work on that. You will have a remainder on this one.
In my house, so if I take x squared, I'm taking x squared, I come to get x like here. Plus 7 plus negative 26 minus 24 over x. That's so weird.
For your remainder.
It's such a weird one. Yeah.
so close to the other way. Agree on it.
Like, meaning that there's like
No, no.
1, and then I'm like, oh wait, it's 28. And then I wrote 24 for some reason, and then I put 28.
It's really nice to brain your hand just don't connect. You know, you're just right something. Keep it like yeah. So, you can two ways. I say the easier way is you can screw it up with the pluses, and then the remainder with all the negatives. If you say minus in the whole fraction, you could like say minus 23. That negative like it's distributed. So that's where. Oh, yeah, they're very active, for sure. Yep. All right, looks like lots of you are getting there. You know, they look worse because you're like, oh gosh, I'm dividing by a trinomial. But it actually goes quicker because you have three numbers that you're sort of eliminating every time. Whoops. Follow my own advice here. All right, so I need a negative x to start with. So negative x cubed minus 4x squared minus 3x. Subtract all of that. I get 7x squared plus 2x. Bring down my minus 3. So now I need a plus 7. 7x squared plus 28x plus 21. Subtract all of that, so negative 26x minus 24. So guys, this is what I was talking about with the remainder. Plus, and then just do your whole remainder in this fraction. So negative 26x minus 24 all over x squared plus 4x plus 3. You get some ugly answers, but that's okay. All right. Questions on that one? Are we feeling okay with long division? We remember it now? Okay, so let's go to synthetic, which is essentially the shortcut in the division world. We have to learn long division as well, though, because synthetic doesn't always work. Long division will work no matter what the problem looks like. Synthetic doesn't always. I'll show you why. Okay, so let's say we have 2x cubed plus 5x squared plus 3x plus 2. And all of that is divided by x minus 2. Okay, what I'm dividing by is this nice linear factor of x minus 2. That is when I can do synthetic division. So up above, like question 1, if I can get there. Question 1, we definitely could have done with synthetic. Question 2 also. But question 3, I have to do that one with long division because that's not just a nice linear thing I'm dividing by. Now, I could have factored it and done synthetic division twice, but it seems simpler to just do long division, okay? So let me just refresh your memory on how synthetic division works. So this time I'm dividing by x minus 2. I think about what would make that 0. So what would make my divisor 0 is a 2, right? So a 2 is what goes on the outside of this weird little box I'm going to draw. And then all I put in here are the coefficients from what I'm dividing. So I would have a 2 for the 2x cubed, and then a 5, 3, and a 2. Okay, so just coefficients there. Okay, so the way synthetic division works, you bring the first coefficient down, so the 2 just comes straight down. That's all I'm doing, I just brought this guy down, okay? You multiply that by what's outside of your weird little half rectangle here. So 2 times 2 is 4, and I write that under the next one. But this time, instead of subtracting, we add. Okay, so long division was all subtraction, synthetic, we get to add. So 5 plus 4 is 9. And then you just repeat that process. So I take 9 times the 2 that's out front on the left, and I get 18. I add, it's 21. I multiply, I get 42. I add, and it's 44. Okay? Anybody questions on where any of those numbers came from? Do you guys remember doing this? Yeah, okay. All right, which of those numbers is my remainder? Yeah, the 44, good. And then the way you write your answer, if you think about it, I started with 2x cubed, and I'm dividing it by an x. So I'm decreasing by 1 degree, like the exponent. It was cubed, now it's going to be squared. So this is 2x squared. And then you just work your way down. Plus 9x, plus a constant of 21, and then my remainder, 44 over the x minus 2. Okay. Questions on that one? Is it coming back? Do you like synthetic better? Oh no. You see a no vote? Yes, back there. Yeah, I like it better too. Okay, I'm gonna have you guys try one. We'll start with some simpler ones, but we could do all of the synthetic division with imaginary numbers too, so just be aware of the saw some scared eyes. It's okay, guys. We'll work up to it. All right, let's try again. So let's say we've got x cubed plus 2x squared plus 7x plus 5 divided by x plus 5. Okay, so try that one with synthetic division. You get a decent sized remainder on this one, so don't doubt yourself. Check with your neighbor, see if you guys agree.
What? Yeah, obviously.
All right, so most common mistake I saw was just in the setup. Remember, it's what would make this 0 that goes on the outside, so it's not a positive 5 this time, it's a negative 5. And then I can do the coefficients. So 1, negative 5, 3, 15, 22, negative 110, negative 105. Okay, so your answer should have been x squared minus 3x plus 22 plus negative 105 over the x plus 5. Okay, questions there? Let's try one more of these. All right, let's do x cubed plus 6x minus 9 divided by x plus 1. Give me a second to try that one. You are, yes, good catch, Matthew. So, guys, when it skips an exponent like this one does, you need a placeholder, okay? So out front would be the negative 1, and then when you do your coefficients, you have a 1, you don't have an x squared, so you need to put a 0, okay? 6 minus 9, okay? All right, guys, what'd you get as the remainder on this one?
-16.
Negative 16. I like it. Let's go through it real quick. 7, 16. All right, so it should have been x squared minus x plus 7 plus negative 16 over x plus 1. Okay. Good with just the mechanics of division, right? Okay. We're going to jot down a couple of theorems next, and then we're going to use those theorems with our division to answer a few other things, okay? So the first theorem is called the remainder theorem. If a polynomial f of x is divided by quantity x minus c, then f of c is the remainder. I'll explain more. Just jot it down first, and then I'll interpret that for you. So let's go back to the problem we just did. So we had, moving on its own here, okay. Without doing the division, if I had just asked you what is the remainder here, I could have done, like this right here is my f of x, this whole little equation here, that's what f of x equals. This over here, guys, is the x minus c. So if I had just substituted in c, which in this case is -1, I would have found the remainder. So if I had done f of -1, that'd be -1 cubed plus 6 times -1 minus 9. Okay, -1 cubed is just -1 minus 6 minus 9. You can see I get -16. Same thing we got over here, right? It's a nice way to check your division to make sure you've done it right. You can just plug it in real quick in your head, and if you get the same remainder, you're like, okay, yeah, I did it right. If your remainder's right, it's very likely you did the whole problem wrong, or you did the whole problem correctly. But if you get a different remainder, then you probably want to go back and check and see what was happening. Does that make sense what that theorem's telling you? You can just plug in the value and find the remainder. Okay. And the second one is the factor theorem. A polynomial f of x has a factor quantity x minus c, if and only if, which you can write IFF, f of c equals 0. Okay, what that's saying, that's what we talked about way back here in the very first example. We went through all of the division and got a remainder of 0, right? If I had done f of -2, like if I had plugged in, you know, what I was dividing by here. Let's see. -2 cubed plus 3 times -2 squared. I can almost fit this. Plus 3 times -2 plus 2. So if I had substituted that in, I'd have -8, and then this would be plus 12 minus 6 plus 2. I get 0. Okay? We already knew the remainder was 0. That's another way we can find the remainder. If the remainder is 0, then it's a factor. You guys see how that's all connected there? Okay. So doing this way of checking, like plugging in what you're dividing by, is a very quick way to see if something is a factor or not. If you plug it in and get 0, you know it's a factor. Okay. Go back down here in case you need the theorems. So guys, any questions on the 2 theorems? Are you confused at all by like the C and the notation, or is it making sense now? Good, okay. All right, stop me if you have questions. All right, so let's use this in a problem. All right, so your directions now say find all zeros given a factor. I think I'm on number 7. So your f of x this time is x cubed minus x squared minus 5x minus 3. And your given factor is x minus 3. Yeah.
Is C -3?
C would be 3. C is like what goes on the outside when you do your division. Yep. So guys, to find all the zeros, you need to get this down to a completely factored polynomial. So where do you think we should start? Division, yeah. All right, so I'm going to divide, and can I use synthetic? Yeah, so I'm going to start with the 3 out here. And if they're telling me this is a factor, what would you expect to get for your remainder? Okay, good. So if you don't get 0, what do you think that means? But it is a factor, so yeah, it means you messed up. Go back, try again. Okay, so let's see if we get 0. 3, 2, 6, 1, 3. Okay, good. I got 0. So I got to x squared plus 2x plus 1. Okay, Okay, great. But what do I do with that now? 'Cause what did the question ask? Yeah, so I'm going to set it equal to 0 since I'm finding the zeros, and then I can factor it. So what does it factor into? What'd you say?
It's -3.
Nope. Yeah, x plus 1 and x plus 1, or x plus 1 squared. Yep. It's okay. All right. So what are my zeros? Like what am I looking for here? Good. So you can list the -1 twice, and then the 3 from before. We don't want to forget this guy. Or you could say -1 and call it a double root, and then the 3. Note in some way that, hey, there are actually 3 zeros here. And remember the degree was 3, so we would expect there to be 3 solutions to this, okay? So either way you want to write that is fine. So does that make sense, what I'm looking for with those directions? Okay, let's try another one of those. Let's do same thing. So you're given the f of x is x cubed minus 4x squared minus 3x plus 18, and your given factor is x minus 3. Apparently I like 3's today. So try that one. Find all the zeros for me. Mm-hmm. Chat with your neighbor, see if you got the same zeros.
then you have the
I didn't put it in shit. Well, yeah, then you're
Daniel, you can check this. Hearing a few disagreements. Not angry disagreements. You guys agree? Oh. Debates are being resolved here. Let's go through them. I'll give you one that's a little trickier. All right, so first, dividing by 3. Bless you. All right, so when I factor this, remember I'm setting it equal to 0. This factors into x minus 3 times x plus 2. So I get 3. Don't forget your 3 from up here, so you can write double root or list it twice. And then negative 2. Are we good? Okay. All right, let's do one that's a little trickier. Okay, this time your f of x is kind of large. It's 6x to the 4th plus 29x cubed plus 30x squared minus 11x minus 6, and you're given 2 factors to start with. Why do you think I'm giving you 2 factors? What's different about this one?
Square root of 4, so you need to divide it twice.
Close. Yeah, the degree is 4. Yeah, exactly. So I would expect 4 zeros. So dividing once takes it down to a cubic. That's not always easy to factor. So I'm going to give you 2 factors. You have to divide twice to get all 4 solutions, okay, or all 4 zeros.
Can you just divide by the same thing?
No, I'll give you 2 factors. Yeah, so you'll divide by the next one. Yep. So let me write both factors, and then you get it down to a cubic, and then you divide by the other factor, and then you're down to a quadratic, and then you should be able to find them from there, okay? So one factor is x plus 2. Your other factor is x plus 3. So guys, go ahead and try this one. I'll give you a few minutes. We'll talk about other ways you could have gone about this one as well. Yeah. Nope. Does not matter which factor you start with. Good question. And I did just make this one up, so I'm double checking to make sure I didn't mess up any of my signs or anything. talk with your neighbor once you are there. Is it cooperating, guys? Finding 4 solutions? Okay, good, good. We'll walk through it, but chat with each other. I'll give you a few more minutes. I know it's a long one. Yeah, so don't forget that these are like trays. Number 6, but quite right. The factor was a leading coefficient of really like this. Remember it. I noticed on the quizzes yesterday, guys, the factoring where there was a leading coefficient. Those are the questions. So we're going to make sure you guys are good with that kind of factoring. Okay? Let's go through it. you had larger numbers here. So I'm going to start with -2. It does not matter which one you do first. So -12, what do I get, 17. And guys, stop me if I like add wrong at any point or multiply wrong. All right, always happy when you get a 0 at the end. Okay, then just straight from there, I can go right into the -3. So I'll bring down my 6. So I have 6x squared minus x minus 1. A lot of you got here, and then the factoring just kind of didn't go great. So let's go through it. There are a lot of different ways you can factor. If you have some great trick that you like and it works for you, fabulous. Do that. I just want you to be able to factor. I don't care how you get there as long as you can factor. I always just think about grouping. So I'm looking for what multiplies to give me -6 but adds up to a -1. So guys, what two numbers multiply to -6 and add to -1? Okay. All I do is rewrite this middle term with those numbers. So I'm going to write -3x plus 2x. That's it. Like I just break that into those two numbers. And then I group and factor by grouping. So I can take out a 3x, 2x minus 1, take out a 1. See how these guys match? That's good. We want that. The stuff that was left over, that's your other factor, the 3x plus 1. Okay? So, my zeros are at 1/2, -1/3, and then don't forget your freebies up above, the -2 and the -3. You should have 4 answers here. Now, if you look at that and you're like, oh goodness, I do not know how to factor with a leading coefficient. We're not going to spend a bunch of class time on factoring because that's definitely something that you should know. But if you don't, if you're like, I really struggle with that, come to Warhawk time, things like that, and we'll get extra practice on that kind of factoring, okay? So don't panic, just know that it is a skill you need moving forward, okay? Now, another way you could have done this problem. Did anybody look at it and go, well, if I just multiply x plus 2 and x plus 3, I can then do long division and I just divide once. That's fine. Those of you that love long division, you could totally do it that way. That's okay. Lots of different methods to get to the end result here. As long as you get there, it works for me. Okay. You would still have to factor at the end doing it that way, so it's not like you can avoid your factoring, but that's just another option. All right, we got just a little bit more to go through. What number am I on? It's 9. All right, for these next couple, we're going to find the given value. Using synthetic division. All right, so let's try this time. P of x is given as 4x cubed minus 2x squared minus x plus 2. And I want you to find P of 3. So before you do any work, stop for a second. Write it down, but that's stuff. Okay, so if it was just function operations and I said find P of 3, you would know what to do, right? What would I do with that? Plug it in, yes. Okay, but I said find the given value using synthetic division. So clearly I mean do something with synthetic division, right? Not just plug it in. What you're going to do with this then is use synthetic division, and what does this represent? Okay, if the fact, yeah, like that you were dividing by x minus 3, and then, but which number from the division does this represent at the end? The remainder, yeah. So guys, this is asking you to find the remainder. Part of this unit is knowing what I'm asking you for, okay? Because if I say find the value using synthetic division and you give me something with an x squared and an x and things like that in it, like, you may have done the division correctly, but you didn't answer what I was asking. Okay, so what this means is I want the remainder. And you are using 3 on the outside there. So 4, -2, -1, 2. Just go ahead and go through your division.
How do you tell it's asking for the remainder?
That is what P of 3 represents. So remember when we wrote down those theorems here? Maybe. Do you see this right here? F of C is the remainder.
Yeah.
So instead of an F function, I had a P function, and C is the number I'm talking about. So what you get at the end is the remainder. Yep. Do you guys get scared when the numbers get big?
Yeah.
Yeah, a little bit. It's okay.
And like that too.
Like 87, 80. It's fine. Okay, so does that, you understand what I'm asking there? Yeah.
So then when you're writing out your answer, would you want to say P of 3 is
Yes. That would be it. So let's do just one more of those that you guys will do on your own. All right, let's say this time P of x is negative x cubed minus 6x squared plus 3x minus 5, and I want you to find P of negative 3. So you guys try that one. All right, guys, what did we get? Negative 41. Good. I'll go through it just in case. So whatever it's the P of or F of, that is the number that goes outside. So P of -3 equals negative 41. Okay? All right, guys, questions? That's the end of your 2-1. Feeling pretty good about these? Okay. We have almost 10 minutes left. So if you want, I just assigned math space to you. It's only 4 questions, so you could get a bunch of it done. When is your math space due? You haven't had a regular homework for a little while. Tomorrow night by 11:59, okay? So you got to get back in the habit of that. And then, guys, you can look in SIS. I did put your test grades in there. You'll see just the letter grade. No, you should be happy. Remember, there were so many gifts given on this. Yeah.
So when I'm taking mine, will I also have to all paper?
You get the lovely different version that is all free response. Okay. I'm sorry. Yeah. Yeah. Good job.
I didn't think that was gonna happen.
So, exit, start on your math space.
I'm scared.
So the grade that you see, that is your combined overall 40% from math space, 60% from free response, 10-point bump, all of that is all in that one grade. Once everyone has taken the test, I'll actually give you the free response back so you can see like the numbers for and all of that. Okay. Any questions? It should be, I just assigned it. If you don't see it, is there? Okay.
Oh, just a pen for there. It's a little bit of a pain. I agree. This is why your homework is only like 4 questions. Okay. I promise I'm reasonable.
I don't know, my teacher last year, we did like 6 synthetic imaging on last week, but like 10 questions, at least.
Yeah. Oh, you were gone last time too, right? Or no? Did you?
I wasn't gone.
You took it, right?
Yeah, I took it.
Okay, what do you mean? Can you take the test?
Retake?
The test? Yeah, did you really talk about the retake? So retake is the end of the quarter, around like October 20 something. And there'll be a main class where you'll have a
Wait,
retake
how
option.
this works?
Do it that way, and then see.
So you can do it then, but there's no. Feel prepared?
I mean, I did. For the most part. Not sure what I got wrong.
Yeah. So, hold on a second. So once everyone's taken it, I'll pass back the response and you will repeat what you said on there, okay?
So for the math space, I'm asking where the motion and
I write this.
Alright. But that's why we do this. Yeah.
You need to like, figure out
That's
how
fair.
much, like the goal that. Okay, yeah. I feel like okay, so like, It's
Too big?
537 times 5.
537. So there's this crazy thing called stretch first.
Yeah, that's fine.
500 times 530. 57 times 5.
So 37. I'm
Gotta work on the math squared, man, okay?
yeah, it is.
Thank you.
Nice. Yeah.
Wait, what did you?
Let's see. Oh, it is not.